We're going to work through 3.7 to 3.8 assignment 3, where we will graph rational functions. Question number 1. We want to graph f of x, so the first thing we need to do is factor. We notice here in the numerator there's an x in common, so we can factor out an x and get this. In the denominator there is also an x in common, so we can factor to get this. Continuing to factor, we still have our x squared minus 2x plus 1 factors to x minus 1 times x minus 1, and x squared minus 1 is a difference of squares, so that factors to x plus 1 times x minus 1. So we factored. Now we can do some canceling, and the canceled factors will help us with our wholes. So x equals 0 is a whole, and then we can cross these two out. X equals 1 will be a whole. So we did that part. So let's go ahead at 0 and 1. We'll put wholes there. All right, zeros. Those are the values that make the numerator equal 0. So on our completely factored part here, x equals 1 is going to be a 0, which actually is where one of the wholes is. So this x equals 1 will help us graph the function, and then we'll go ahead and put a hole there on the graph. Vertical asymptote, values that make the denominator equal 0, so that's at -1. So we have a vertical asymptote at x equals -1. Horizontal or slant asymptotes, we have to look at the degree of the numerator compared to the degree of the denominator. Right from the beginning, we had a 3 and a 3, so before factoring, we had they were equal. After factoring, we still have that they're equal, because if we look over here, it's a 1 and a 1, so they're equal. And so the horizontal asymptote is at y equals the ratio of the leading coefficient of the numerator, which was 1. We can look at the very beginning there, and the leading coefficient of the denominator, which is 1. So 1 over 1 is 1, and we have our horizontal asymptote there at 1. And then for our y-intercept, we would plug in 0 for x. However, we have a hole at x equals 0. Now, we could put a dot here because that will help us graph it, but there will be a hole there. And then we want to graph. We have one asymptote. So that one asymptote splits the graph into two sections. So we will see where we can graph here. Let's use orange. So it could either be this orange section or this green section. And as we think through this, and I say it could be one of those two because we have to use the vertical asymptote here. I'll just retrace. We have to use the vertical asymptote, then the horizontal, and over here we have to use vertical, then horizontal. So it's got to be one of those two. However, it can't be the bottom one, because in order for it to be this bottom one, it would have to cross the x-axis somewhere, and there are no x-intercepts there. And so the orange one is what we want. And then we're going to graph the other part. So our vertical asymptote is at x equals -1. That's multiplicity 1, which is odd. So on the left side of the asymptote, it goes up, which means on the right it needs to go down. And then we need to go up. We need to hit this point, and then come around again and hit this point. Actually, that is not true. I should not have put this 0 here. It comes up and hits. And the reason it's not a 0 there, I should have been looking at the end here. There are no intercepts. There's no y-intercepts. Well, yeah, sorry, we can put a 0 in here. I apologize. So coming back to y-intercepts, y-intercepts, way back to y-intercepts. If you put 0 in there, you get negative 1 over 1, and so the y-intercept should be negative 1. So we have a y-intercept of negative 1. And it has to go through this 0 and then gets closer and closer to the horizontal axis. And then last thing we need to do is take into consideration the holes. So there's a hole here at 0, which was kind of at our y-intercept. So I'm going to put there's a hole there. And then also there's a hole at 1. So I'm going to erase that and put a hole. And now we have our graph for number 1. All right, moving on to number 2. Once again, we need to factor first. It's not factored for us, so let's just work with the numerator. X squared minus 5x plus 6 is going to factor to x minus 3 times x minus 2. The denominator, there's an x in common, so we can factor out an x, and we're left with x squared minus 6x plus 9. And then we can factor this to x minus 3 times x minus 3. So it's factored. And then we look for holes. Well, holes, we look for things that cancel. So x minus 3 cancels with x minus 3, which means there's going to be a hole at 3. So at 3, we'll go ahead and put a circle down here. We'll see a vertical asymptote here. So that's going to change things up here a little bit, which we'll talk about. Zeros are values that make, so once everything's factored, zeros are where values that make the numerator equal 0. So that's at x equals 2. So we will put a point at x equals 2. And we remember, never mind, x equals 2. And then we move on to vertical asymptotes. That's what makes the denominator equal 0. And that's 0 and 3. So we put vertical asymptotes at 0 and 3, which I have. And this one at 3 here, a asymptote trumps a hole. So both of them say that 3 can't be part of the domain, but yeah, it will be asymptotic there. Horizontal or slant asymptote. This one's pretty simple. So right from the beginning, we can look at the degree of the numerator, which is 2, compared to the degree of the denominator is 3. So we're looking at degree of numerator compared to degree of denominator. The degree of the numerator is less, so therefore the horizontal asymptote is at y equals 0. So there's our horizontal asymptote, which horizontal asymptotes have to do with the ends of the graph. And so now we have 2 vertical asymptotes, which splits our graph into 3 sections. So we will have 3 branches as part of our function. So it'll be in 3 sections. So let's pick a section. So if we've a lot of times been just doing the leftmost section. So if we could have this option, the black one, or we could have this orange option, and actually both of those are okay. So this wasn't a good way to determine where the graph could be. So we're going to get rid of both of those. In the middle section, not much helps us there. And in the rightmost section, nothing much helps us there. So we can't use our previous kind of eliminate what doesn't work. So one thing we can do, which we haven't done much, is we can, especially since we have our horizontal asymptote at 0. I'm just going to show something here. In this pink section, things above the x-axis, our function would be positive or above 0, and things below the x-axis would be negative. And so what we can do, there's a few things we can do. We could, which doesn't have to do with what I just told you, we could pick a x value in this section, not 2, and see where that is, and that would tell us if our graph is above the x-axis or below the x-axis, so we could figure out what it is. So that's one way. So for instance, we could take x equals 1 and put it into our function, probably this, our most simplified function, put x equals 1 in there. So we would have 1 minus 2, and they would have 1 times 1 minus 3, and that gives us negative 1 over, that's a 1 minus 3 there, so over negative 2, which is 1/2. So when we put in 1, we get a half. And now that can tell us about the rest. It can't come from here because we would have to cross over the x-axis to get to this point. And so our graph will start up here, go through the point we just found, go through the x-intercept, and then get closer and closer to the other vertical asymptote. And from there, we can use our asymptotes to find the other sections. So the asymptote at 3, that just happened once, and 1 is odd. And so since to the left, this went down, to the right, our function will be up. And so it will come down and then cut closer and closer to the horizontal asymptote. And then we can come to, let me just highlight it, we can come to this pink asymptote, and that's at 0. So 0, our vertical asymptote at 0 that only occurred once, which is odd, so they have to go in opposite directions. So since it went up to on the right side, it has to be down on the left side. And so it would come up and get closer and closer to the horizontal asymptote at 0. So that was one way to do it. We found a point at x equals 1, and then we were able to figure out what our graph looked like. One other option. So that's the answer right there, that graph. One other option we could have done is we could have thought about a really big number way down this way on the x-axis. Let's just even say 100. So if I plugged 100 into here, I would get a positive number. 100 minus 2 is 98. I don't really care much about the 98. I care that it's positive. If we put 100 here, we would get a positive number. And so a positive over a positive is positive, which means on this horizontal asymptote here, we would want to be above it, because above the x-axis is positive. And so we could know it was above the x-axis, which means it would have to be up here, and so it would have to go up this way. And once we knew that branch of the function, we could know the other ones. Question 3. First, we have to factor. So we have an x squared in common. Better yet, we like our first term to be positive if possible. So we're going to factor out a negative x squared out of the top. So we factor out the negative squared, and then we get x squared minus 4. X squared minus 4 factors to x plus 2 times x minus 2. And so we factored. However, we can cancel here. 2 of these x's can cancel with 2 of these x's, so this would be a squared. And so you have your ending result here. And the 0 canceled, so there would be a hole at 0. We can always tell that's going to be a little bit, there's going to be kind of a extra thing to think about, because there's still an x squared involved, which means 0 will be something else. Zeros, so looking at our final factored and canceled graph there, zeros occur at values that make the numerator equal 0, which are at negative 2 and 2. So let's go ahead and put a 0 at negative 2 and a 0 at 2. Vertical asymptotes are values that make the denominator equal 0. And so that's 0, and that's multiplicity. I didn't write it on here the first time, but that's multiplicity 2. And so it will kind of, in quotes, bounce off infinity. So we have a vertical asymptote at 0. And then we're going to look at our horizontal or slant asymptote, which we can just look at the leading coefficient, the degrees. Degree of the numerator is 4, the degree of the denominator is 4. That was before we canceled, and that's really easy to look at over here. And so we can just use that. They're equal, and so we want to look at the leading coefficient of the numerator, which was -1, over the leading coefficient of the denominator, which is +1. So we have a horizontal asymptote at -1. And that is drawn in right here. No y-intercepts, because if we put in 0 into the denominator, we would get a 0. So no y-intercept. And now let's see what we have here. Hopefully we're getting better and better at this. If we look at the left side, we would have to have a vertical asymptote and get closer and closer to the horizontal asymptote, which works out well because we passed through that 0. Compared to this green possibility where it goes to the vertical asymptote and the horizontal asymptote, but it would never hit the x-axis, but we know that it has to. So it has to be the orange section that we graphed. Now we come to our vertical asymptote. The vertical asymptote came from x equals 0 multiplicity 2. So since the left side was up, the right side also has to be up. We talked about bouncing off infinity, so that's going to come down. Again, we see we have a 0 here to cross through, so we're going to come cross through that 0 and get closer and closer to the horizontal asymptote. We had a hole here at 0, but vertical asymptotes trump holes, so that's not even of concern.